It's horrifying, huh? Well, that was fun. Um, hopefully, I didn't make anybody spit coffee out their nose or anything, or yeah, whatever. Um, so, we are going to take a look at another example of a mixed circuit. This will be the last one of these, and then I think after this, we are on to looking at what happens when we combine capacitors together. This will be I think the last thing on this particular topic. So this video, we have another one of the Plicker style questions, actually a couple of them. So if we were sitting in class, I would ask you guys to, take a look at this and think about it. Well, first off, let's talk just for a minute. We've got all kinds of different resistors here. All the values of the resistances are listed up in the text at the top. Our goal is to, at least in part A, to figure out the total voltage supplied to the circuit. And then part B is to figure out the current in the circuit. One thing that I want to point out that you may have noticed already is that we've got two different, and why is my pen not working? Oh no. Huh. Finger works. All right. We have two different power supplies there. And so we haven't seen anything like this before. Well, maybe a little bit. We saw back last week something, a couple batteries in a flashlight. But here we got a couple power supplies. And so our first task is going to be to figure out exactly how we handle this. So let's see. What I need you guys to do is to take a look at this and figure out, well, what is the total voltage that's actually being supplied to this circuit? We've got two choices here. Either it's 40 volts or 20 volts. So pause, think about it. Okay. So the answer is that it's 20 volts. Well, why is that? If we take a look at these two power supplies, we'll see that this one right there has got the positive side up, the negative side down. This one right here has got the positive side to the right, the negative side to the left. And if you look at them, this 30 volt power supply is trying to drive current basically clockwise, I guess, around the circuit. On the other hand, this 10 volt one is trying to drive current basically counterclockwise around the circuit. So they're opposing each other. So as a result, we can, and the fact that well, they're all kind of on the same branch, at least as far as the power supplies go. They're opposing each other. So our total voltage here is going to be 20 volts. And we're not going to see anything more complicated than this. But anyway, so 20 volts is our answer for that. And then our next question deals with the current. So here we've got basically four choices. And if we were in class, I would, at this point, just give you guys a couple minutes to walk through this and try to solve this on your own. What I would like you to do well, it'd be great if you tried to do that, but I would like you to, at the very least, kind of think about what steps should I take to try to figure out my answer. So think about that, pause the video, and now I'll give the answer. Okay. The answer here is actually that it's 0.5 amps. That's how much total current we've got in this particular circuit. Of course, the question is, well, how did we get there? How do we know that that's the right answer? All right, so if we take a look, I've got this, my circuit still up there. What I need to do is I need to figure out, okay, well, what is my total resistance? Okay, so what is R sub T? Well, if I take a look, I just have to kind of start combining these resistors to figure out what my total resistance is. If I knew my total resistance, then I could use Ohm's law, V is equal to IR, there to figure out what my current was. All right, so R3 and R4, they are clearly in series with each other. So I'm just going to go ahead and combine R3 and R4. So this should say R sub A is equal to R3 plus R4. R3 is 10 ohms, R4 is 10 ohms. So when I combine these two together, I get a total resistance of 20 ohms there for my equivalent resistor, or equivalent resistance for those two in combination. All right. So at this point, we're going to redraw things. We're going to do our best anyway. There's R1. There's R2. There's RA. There's our second battery. There's R6. There's R5. And then we're connecting up to there. Now, if I take a look at this one, now that I've got this redrawn, I can see that, well, those two right there are in parallel. That's R sub 2 and RA are in parallel. Also, R5 and R6 are in parallel. Those are very clear, simple combinations of parallel resistors. So as a result, I can go through and I can try to solve for equivalent resistances for each one of those. So we'll call this one right here R sub B, and this one right here R sub C. So 1 over R sub B is going to be equal to 1 over R2 plus 1 over RA. Now, when I plug in the values for R2 and RA, that's 80 ohms and 20 ohms. I get 1 over 80 ohms plus 1 over 20 ohms. I can figure out that R sub B is equal to 16 ohms. Right. Give myself a little space here. Okay, so R sub B is equal to 16 ohms. That's great. Let's figure out what R sub C is. Okay, so 1 over R sub C would be 1 over R5 plus 1 over R6. And R5 is 20 ohms. So this is 1 over 20 ohms plus 1 over 60 ohms. When I do the math on that, I get 1 over R sub C is equal to, well, you know, if you add these up as fractions, which we could do if we know how to do that in our calculator, or we could just do 1 divided by 20 is what? It's 0.05. Of course, we let our calculator tell us that. 1 divided by 60 is whatever that is. And we can go through and figure this out. Well, let's see. This is going to give me that R sub C is equal to 15 ohms. Okay, great. So I've got that. I've got R sub B. And what I can do now is I can redraw this circuit again. I've got R1 there. I've got RB there. I've got RC there. So R1, RB, and RC. Now those three guys, those three resistors are all in series with each other. If I look at the pathway that current might take, all the current that goes through R1 has to go through RB, has to go through RC, and just so on and so forth. If I trace out that current, that means that these guys are all in series together. So my total resistance there is going to be equal to R1 plus RB plus RC. When I stick in my values, 9 plus 16 plus 15. This gives me a total resistance of 40 ohms. And then, okay, I can figure out my total current. That's going to be voltage divided by resistance. This is what, 20 volts over 40 ohms. And that leads me to the result that I gave you guys back on the previous slide that my total current is 0.5 amp. All right, that does it for this one. Thank you very much.